You are running a perfectly smooth operation, and suddenly a sensor trips. The entire production line stops completely. Frontline managers face an immediate dilemma. You have to get production moving again quickly, but you have no idea if this is a minor fluke or a deep systemic structural flaw. To solve operational failures, organizations typically reach for one of two heavyweights in process improvement: PDCA or DMAIC. Guessing wrong always carries an objective cost. Deploying a heavy framework for a light problem burns thousands of dollars in wasted man-hours. Using a light framework for a deep problem guarantees the defect will return tomorrow. The decision between these two is not about identifying which is superior. It is a strict calibration of agility versus analytical rigor. On the surface, PDCA and DMAIC look similar because they are both cyclical improvement models. In execution, they operate under entirely different rule sets. This image illustrates PDCA as an apple. It is a straightforward cycle built on 4 basic phases: plan, do, check, act. This structure is designed to be continuous. A team can digest and deploy these 4 steps on the floor immediately without any specialized analytical training. Looking at the bottom half of the image, DMAIC is the orange. It demands 5 distinct, highly structured analytical phases. Like apples and oranges, you cannot swap one framework for the other and expect the same outcome. They are engineered to survive in completely different operational realities. PDCA lives on the front line, where downtime is expensive and speed matters. Teams skip gathering extensive new data and instead rely on their existing experience to form a working hypothesis. The defining feature is the rapid do phase. You test a fix immediately on a small scale to see if the line starts moving again. The trade-off for this agility is severe. PDCA contains no mathematically rigorous analysis phase. Because you bypass statistical validation, your team might successfully replace a jammed gear, completely missing the hidden voltage spike that caused the jam in the first place. PDCA provides value by maintaining continuous momentum and securing quick wins. It is not designed to guarantee an absolute systemic cure. DMAIC, on the other hand, belongs in high-stakes engineering or Six Sigma projects, tackling chronic, extremely expensive variations. The burden begins immediately in the measure phase. Before any action is taken, teams must undergo structured, tedious new data collection to baseline the current state. In the analyze phase, teams use statistical validation to isolate the exact root cause. You let the math prove what broke before you try to fix it. Finally, the control phase acts as a lock. It implements monitoring systems to ensure the new solution becomes a permanent structural change that cannot regress. This certainty